10. So it will be slightly faster when compared to this. So at the time you drop some of the features or some of the nodes, it will be somehow going to be increase your efficiency to compute. So this is a much more easier way to understand the dropouts. So you can also specify to mention dropouts by default is going to be 0.5. You can specify it in terms of 2.2 or 0.3 like that. So it will eventually get in terms of the probability value, then it can drop off. So that is one of the hack. And another hack we're going to be showing in this notebook like VGG16. VGG16 is also very helpful at the time. So eventually what will happen, you have to trial and error method, that's it. So no need to worry about what you have to do. You have to, if you know the some of the hacks, you can trial and error method. Slightly going to be overfitting, underfitting, along with the loss values may not be satisfied, get the training data and testing data. We can also build on top of the multi-class classification setting. So since we are already only learning with steak and pizza, so why, I mean, if you have more number of the other object or more number of other stuff, you're going to be take consideration like a 3-class classification setting or 4-class classification setting. At that time, how does CNN going to be works out? Let's trial and error method this. Yeah, let's go with this. So I will explain the VGG16 tomorrow maybe. So let's hold on this VGG16, but try to understand how does it going to be works out with the multi-class classification setting with corresponding to the data what we had. Yeah, this is a flaw I can say in the TensorFlow format. We had to go with only the TensorFlow because I'm the only person who biased towards the TensorFlow. We can also go with the PyTorch, but PyTorch may not be make sense that much of the good results. You may not be understood that much also because PyTorch somewhat slightly trickier than the you can say TensorFlow. So getting ready for the data, and yeah, you will get some of the data like different images, and you will also get from the TensorFlow hub like building a pick and some of the pre-trained mechanisms what you had, fitting of the model corresponding to the number of the hidden layers and whatever the layers are going to be showcased for the input image, then evaluating, comparing and running and save your model. So I will show you one simple architecture of this framework like CIFAR. So if you go and see how does that going to be helpful in the TensorFlow, this is much appreciated I can say when compared to whatever we learning in the binary class classification. That's makes so long notebook, you can say long notebook. I will do 100 models also. I'm not satisfied with that. 100 models also I'm not satisfied. This is one of the disadvantage I can say to, to waste my time, to waste my time. So at that time I realized this is not a good proper approach to do any kind of the model. So for that I will go and see this framework, whatever we learn in the TensorFlow hub from to get some ideas around with the TensorFlow also and early staffing also. So you can see, yeah, we are declaring some of the bunch of the variables corresponding to that. So this is the different, different, you can say data set, CIFAR. CIFAR consists of the large number of, you can say colored images and some of the different objectives, but just we are just taking consider for the 10 objective itself. It consists of the 6,000 images per class. So these are some of the research fellows have implemented this data set. I can say they are collected and they have done some of the research on the CIFAR. So CIFAR is very popular. If you want, you can also download CIFAR 100. That is also very useful to get some insights. So currently I'm just taking as a number of the classes 10 and batch size for each time I'm going to passing the 32 images. EPUBs I'm just passing 3. So just for understanding purpose, you can pass maybe 100 or 1000 so that it will be much more gives a good results. And learning rate, I'm just passing the 12 and along with the number of the filters, compression size. So yeah, you can see we're just loading from the Keras. Okay, so Keras having the predefined data set called CIFAR 10. You can directly load the data. So since we already know how to load these data sets and comparing with the results with somehow test and training data sets, I'm just skipping this part. Yeah, so if you go and see, yeah, so these are the some predefined blocks I can say, transition block, input block, and also the output block. So yeah, if you go and see this training mechanism, how does this going to be works out? So if you if you go and see this one, The random seed and random seed number of the filters we have already declared, and the dropouts also we have take consideration for the 0.2. So you can see this layer is somewhat slightly different with whatever we learn. So the input shape, I'm just passing through my input image, height, width, and channel so that it will be convey, it will be rescaling my data every time. So we have declared that function actually. The dense block with corresponding to the input, number of the filters and the dropouts, and along with the input and filters and the dropout. So every time it's going to be take that following up so that it will be iteratively going to the rescaling of the data every time. And since we already know first convolutional I mean first layer, second layer, third layer with corresponding to the each and every block. So what will happen if you directly pass with respect to the, suppose we have already shown the model 8, model 7, right? So what will happen with corresponding to showcase like this? Yeah, so where is this model 7? Yeah, showcase like this, it may not be helpful that much, because every time you are giving the specific results, or you can say unique results. So instead of this, what we are going to do corresponding to some kind of the tricky nature, number of the filters I'm just considering the 18. But what will happen eventually, the iteration process came into the picture for the number of 18s. It might be a less, it might be a plus or minus, you can say, for that matter. So I'm just filtering out with corresponding to the input shape, along with the styling, padding, everything. We are going to be pass those parameters. And dense block, we already defined the dense block on top of it. So just taking the dense block and which first convolutional duty we are going to be take consideration, and just applying the filters, applying the dropouts. Similarly, applying the filters and applying the dropouts for the second and third block, and also the last block. So what will happen if you eventually pass with corresponding to the number of the filters and the dropouts, and also the dense layer and transition and also the output layer, output block, you can say. So this functionalities will going to be helpful eventually iteratively, in terms of whenever you training your model, you can say a pops of 3, it's going to be learned together. And what will happen if you use something called as a early stopping by using the TensorFlow? So tensor board, it's going to be very helpful. You want to be get to know which value is going to be smoothing off. Suppose we already seen training error and test error looks like this. Looks like this. So at the time you face this much of the difference between the training error and test error. So this is much more overfitting of the model. At the time you realize these are the number of the epochs was first epoch, second epoch, third epoch, fourth, fifth. At the time fifth epoch, you are not getting the good results even. At the time third epoch, you are getting slightly good results, but not that much of higherness. At the time you get as a second epoch, the good results, but not higherness. So these things will be counted, right? These things will be counted. For this, I have drawn a tensor board. So it will throw a board for me as a tensor flow. So I will get number of the epochs, are also called as a smoothing curve, to get this curve in terms of the epochs, x-axis as the epochs and y-axis as a loss, so that I will conclude that which epoch is going to be give as the less loss.